So now the concept of continuum you people understood better. Now we are going with another one topic, that is fluid properties. So here we have to understand each fluid. That means fluid means I have mentioned liquid, gaseous, or it may be solid. So fluid, that means you take any kind of fluid. It may be honey, it may be blood, or it may be water, or any kind of fluid having different parameters, like in terms of properties. So here I have summarized some properties which are related to fluid properties commonly. So before going to understand the basic properties of a fluids, so one you can take mass density. So here you can see mass density, and another one is specific gravity and specific volume and specific weight of the fluid. And coming to the other kind of criteria, see, these are the basic things: mass density, specific gravity, specific volume, and specific weight. But coming to the criteria where we have to focus: viscosity, vapor pressure, surface tension. And moreoverly, we need to understand what is capillarity and compressibility and elasticity. So here the mass density and specific gravity and specific volume and specific weight, everything it's having kind of basic definition things, but we can understand by seeing the definition. But coming to the scenario of viscosity, surface tension, and capillarity, you people need to understand the concept. So as I mentioned earlier, the units, SI units we are following, which is standardly acceptable entire world. So now we can see one by one what is mass density, what is specific gravity, what is specific volume, and specific weight. And after that we will see viscosity, surface tension, and vapor pressure, as well as capillarity and compressibility, as well as elasticity. So now the first one, mass density. So before going to the C, first we will go with some kind of formula. Mass density is the mass of a fluid per unit volume. That means there is a mass of a fluid with respect to the volume. Now you take the best example, cork. So when you put this cork on water, it will float. That means here the difference is the densities. So this clearly explained in the upcoming lectures. For example, if you have taken normal water and salt water, then try it with one lemon, put it. One will be completely, it will go down bottom of the water, because water and if it is a salt water, it will float. That means the both, because of the density. If density of a liquid is higher, then it will float like that. So cork is having water and wood is having partially floating the density, so it will float, and metal is having more denser, so it will get into the water. So now you see water is having more density and cork is having less density, and water is having and wood comparatively more or less equally they are balancing, and water is having very less density, but metal is having more density. So more density means it will go into the bottom. Now you see it is denoted by a Greek letter called rho. So you can understand rho. The unit of mass density in the SI units is kilogram per cubic meter. So this is a very important, where you people need to understand kilogram per meter cube, its unit. What is kg? Kg is mass. Obviously volume always will be in meter cube. So mass of a fluid per unit volume may kg per meter cube. And the density of water, suppose they are telling the density of water at 4 degrees centigrades is 1000 kg per meter cube in the SI system. So water, the density of water at 4 degrees centigrade is 1000 kg meter cube per 1000 kg per meter cube in the SI system. So that is what mass density. You can see the formula. Rho means density, m means mass, v means volume. So rho equal to mass by volume. So density of cork. So density of cork is less than, you see, density of metal is more when compared with wood, and density of wood is more when compared with cork. So that's the differences. So first one, in a simple sense, you can remember this easy formula where you people can understand rho equal to mass by volume. And coming to the another one, that is specific weight. So specific weight is the weight of a fluid per unit volume. Previously it is mass, now it is weight. See, that means it is denoted by the word gamma. Previously rho equal to mass by volume. Now specific weight, now we are discussing about only weight. So now it is weight by volume. So this is what specific weight, weight by volume. And coming to the units, it is Newton per meter cube. Now let us see the step by step calculation, like how we got that value. So now mass density equal to rho, as we know. So rho equal to mass by volume, that is equal to units also we have mentioned kg per meter cube. Now as we know weight, if we want to see some weight, we have to see mass, that means what is the weight, and with respect to the gravity, whether it is in earth or moon or something. So weight is nothing but, in a simple sense, mass into gravity. So weight equal to m into g, and this is m mass into gravity is always unit is Newton. Weight is always unit is Newton. That's what we have written in SI system, Newton per meter cube. And coming to the specific weight, gamma is equal to W by weight by volume. As we know, W equal to M into G. Agree? So weight equal to M into G. Or volume is obviously volume. Now substitute M by V. So rho equal to M by V, that is equal to mass by volume, that is equal to density. So substitute here. Then this will be gamma equal to rho into G. This is the final product. So gamma may be rho into G, or else gamma equal to W by V. Whatever it is, everything is right. But you people need to remember the units Newton per meter cube. That is very, very important. Now we are going with another property called specific volume. So specific volume is a volume occupied by a unit mass of a substance. So here previously we have gone mass, density, next specific weight, next specific volume. It is denoted by V. It is denoted by V. The unit of specific volume in the SI system is meter cube per kg. See, what is rho? Rho equal to M by V, and units equal to kg per meter cube, right? Agree? Now it's just a reverse to that. Specific volume is nothing but it is having some denoted by mu, like V, right? It is by volume by mass. Mass by volume is nothing but density. Volume by mass is nothing but volume. So volume is dominating here, to remember. And it is also a reciprocal of density, as I mentioned now. When where this is specific volume, this is V is equal to volume, and this is M is equal to mass. So units are with respect to meter cube per kg. So another basic fundamental one is called specific gravity. So specific gravity is the ratio of the density of a fluid to the density of a reference substance, typically water for liquids and air for gases. And it is denoted by V, no units, like this is a dimensionless one, specific gravity. That means density of fluid to the density of a reference substance. See, density of a fluid to the density of a reference substance. Typically water for liquids and air for gases. Now you see the reference. Now you see the reference. Water is 1. And the density of wood is 0.6 and ethanol is 0.78. So here wood is having less density. Now you compare, water is more denser. That's what wood will flow on that particular water. As I have shown previously, here you can see the second image. Wood is floating and water is here. It is floating on the water and cork also. That means from here you people can understand wood is floating on the particular water, means it is the density is less density, that's what it is floating. If density is more, like iron or cement, such that it will go to the bottom of that water, because these two are can have a density more. Understood? So less density means it will float, more density means it will go into the water. That means it will submerge into the water. Now to remember, to understand you, I have taken a reference source from Google Images and I have made some kind of thing, density, mass and volume. So density, you see, you remember this triangle MdV, 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 MdV. If you want D, then you just see mass by volume. Just make it, because this is above division and this is multiplication. MdV, right? So density is equal to mass by volume. Mass equal to density into volume. Next, volume equal to mass by density. So like that you can able to remember in a quick manner. So understood each and everything. If you remember this triangle, you can understand what is what. Simply, no need to remember volume. Volume equal to mass by volume, or density is equal to volume by mass. No need of any kind of confusion. If you have this triangle such that you can crack easily and you can remember it. So density equal to mass by volume and volume equal to mass by density. That's the only way we can do. Coming to the quiz point, still now I have discussed some points. Now you people need to judge yourself and give the answers. So the first question, what is the SI unit of mass density? Now you think mass density, SI unit. So density equal to rho equal to mass by volume. Mass equal to some weight, that is equal to kg. Volume equal to units meter cube. Where we are able to find this thing? kg per meter cube. So what is the SI unit of mass density means, if you know the formula, otherwise if you know this m chart d into v, so density equal to mass by volume. That's it. If you know this shortcut, you can remember. That is very simple as that. Shall we go for next problem, next MCQ? Next one. Specific volume is defined as. Now you tell specific volume is defined as so this is also depending on this circle. Volume equal to mass by density. Where is there mass? Volume equal to mass by specific volume equal to volume by mass. So volume by mass. This we cannot use this thing. So it is B. Volume per unit mass. Volume per unit mass. That is called specific volume as defined. Volume equal to mass by density. Mass by density. Then we can go with volume by mass. The relation between specific volume and density is, so here the relation between specific volume and density is, density is always inversely proportional to specific volume as I mentioned. So it is B, volume equal to 1 by rho. So next one, specific weight is defined as, so it is asking weight, so weight per unit mass. So next one, specific gravity is defined as, specific gravity they are telling. Specific gravity means density with respect to reference density, density to density of water. You can see the key here. First one is C, which is kg per meter cube. Second one is volume per unit mass. Third one is V is equal to 1 by rho. And fourth one is weight per unit volume, density or density of water. Now coming to the another concept, that is viscosity. So viscosity is a property of a fluid that resists the movement of one layer over another, which will resist the movement of one layer over other layer. And high viscosity means fluid flows slowly. Example, honey. Viscosity of honey is high and viscosity of water is low. So it will fluid flows easily. So high viscosity means slowly it will go. Low viscosity means easily it will go. So Newton's law of viscosity tells us how much force is needed to make layers of fluid slide over each other, that is equal to Newton second per meter square or kg per meter second. Now you can take, here it is a water, here it is a honey. See, for honey, for filling that water, it will take quickly. Water, it will take quickly to fill, but honey, it will take time because high viscosity. Viscosity means viscosity is resistance of properties that resist the movement. So it will resist the movement of the flow, but it will be easily can be done. It is resist the flow. So it will take long time. It will take less time. In a simple sense, tau is equal to mu into du by dy. This is a standard formula. So tau is equal to shear stress. How much shear stress is happened? Newton per meter square. So mu is equal to dynamic viscosity. Now du by dy is velocity gradient between fluid layers. In a simple sense, honey always resists the viscosity, that is always resist the flow. So water it will go in a flow. Now thicker fluids like honey or oil have higher viscosity, so they need more force to move. And thinner fluids like water or air flows easily and needs less force. So kinetic viscosity and dynamic viscosity we will discuss. So kinetic viscosity is nothing but is a ratio of dynamic viscosity to the fluid densities, that is meter square per second. So kinetic equal to, this is kinetic viscosity because this is a dynamic viscosity by mass density of the fluid. It shows how easily a fluid flows under its own weight without considering external force. Now you see water having low viscosity, as I mentioned, it will flow very quickly. Olive oil have a medium viscosity which will flow, but it's not much quicker than water. And coming to the honey, it will have high viscosity where it will take long time to flow the spark. So viscosity, now you people can understand. Now vapor pressure. When a liquid is kept in a closed container, when a liquid is kept in a closed container, some molecules at the surface gain enough energy to escape into the air as vapor. As the temperature increases, the vapor pressure of a liquid also increases, as we know. So here in a flowing fluid like in pumps or turbines, if the pressure drops to the liquid's vapor pressure, bubbles from due to vaporization. These vapor bubbles are then carried to area of high pressure. There they collapse suddenly, creating a shock waves and tiny explosions. This leads to damage or corrosion of a metal surface blade like blades or pipes, etc. This damage process is called cavitation. That means, see, in a hydrological cycle, you can see the water from the surface to atmosphere will escape through a medium called vapor. That means from transpiration, that is escaping water from plants leaf, that is through stomata, that is called vapor. So liquid is converted to vapor and vapor reaches to the atmosphere clouds, then atmosphere clouds will get back to the rain. In the similar way, if there is a vapor pressure, that means if vapor pressure is there inside the pump, if the pressure drops to the liquid vapor pressure, this I will explain in the upcoming slides. What is the pressure drops when it will come? If it is collapses, then suddenly collapses, shock waves will happen and explosive tiny explosion. This leads to the damage or corrosion of metal. That is called cavitation. Next, compressibility and elasticity. All fluids can be compressed when an external force is applied. So anything we can compress. And when that force is removed, the fluid tends to return its original volume. Okay, we will compress and it will come to the original volume. This behavior shows that the fluid also have elastic properties similar to elastic solids. The compressibility of a fluid is quantitatively expressed as the inverse of the bulk modulus of elasticity K, which is defined as K equal to stress by strain dP by dV by V. Change, that is equal to K is equal to change in pressure with respect to change in volume by original volume. Actually it should be original volume, that changes happen with respect to the pressure. So because of compression. Now surface tension and capillarity. This is also one of the important thing. Now capillarity is the ability of a liquid to rise or fall in narrow tube due to surface tension and adhesion forces between the fluids and the tube. Now what is adhesion, what is cohesion, what is concave, what is convex, everything we will see with respect to this table, and we'll come back to these figures. So now you take some cases. Water in a glass. Okay. So if it is mercury in a glass, so no wetting or white tube. Now water in a glass, you see adhesion is greater versus cohesion. If adhesion is more than cohesion, that means the capillary rise will happen. You can see this is what I mean. So adhesion is greater than cohesion, then capillary rise will happen. Then this is called concave. If cohesion reverse, if cohesion is greater than adhesion, capillary fall will happen. That is called convex. So concave means rise, convex means reverse. Now white tube is nothing but that is a flat or neutral, no capillarity. Now you see this is positive is maintained with respect to some 0 to 90 degrees and 90 to 180 degrees and 0 theta equal to 90 degrees. So now before this, to understand this formula, I want to give you one simple thing of the definition. Surface tension is a property of a fluid that causes its surface to behave like a stretched elastic sheet. It results from the cohesion forces between liquid molecules, especially those at the surfaces. That means, in a simple sense, force per unit length acting on along the surface of a liquid. Now you take cohesion, you take adhesion. So cohesion is the attraction between molecules of the same substance. That means take water. Adhesion is nothing but the attraction between the molecules of different substances. That means this water strider with respect to water. See, first criteria cohesion is this between same substance, and adhesion means different substance which is having good bond, water striders. Now you take here, if adhesion, that means different material is having more attracting towards same material, then you can call it as a capillary rise, then it will rise. For example, same substance dominates than different substance, then it will have a fall. If both are having neutral or flat, both are agreeing mutually, then it is a zero capillary action. That is what here we have mentioned. And there is a formula derivation H is equal to 4t cos theta by rho gt, rho gd. Now H is equal to height of the capillary rise, and T is equal to surface tension. T is equal to contact angle, as I mentioned, 90 degrees or 90 to 180 or 0 to 90. Rho is equal to density of liquid. G is equal to acceleration due to gravity, and D is equal to diameter of the capillary tube. So that's it, today's lecture. So once we will come the glimpse, then you people can understand. It's a kind of revision. So now we have seen initially properties of fluids, mass density, specific volume, specific gravity, specific weight. Then important things like viscosity, that honey we have discussed, surface tension, that water traders we have discussed, vapor pressure, cavitation we have discussed, compressibility and elasticity, that bulk things we have discussed, and capillarity. Now mass density means mass density in a simple sense, rho is equal to mass by volume, and unit is kg per meter cube. And specific weight is nothing but Newton per meter cube, and units is Newton per meter cube, and specific weight is rho into g or W by V, and volume equal to reverse to the reciprocal of density, that is called V by M. Gravity is nothing but, if gravity, specific gravity means density of a fluid to the density of a reference substance. So lighter one, wood, ethanol will float, higher one density, iron rich soil or cement will go down. This is a basic thing where you can remember in a simple triangular thing. And what is the SI units means kg per meter cube, and specific volume is volume per unit mass, and relation between specific volume and density is V is equal to 1 by rho. Specific weight is weight per unit mass, and specific gravity is defined as the ratio of density to the reference density, that is the density of the water. And these are the key for that. And viscosity, as I mentioned, high viscosity is honey, so it will take lot of time. So water is low viscosity, so it will fill quickly. And there is a resistance, the movement of one layer over the other layer, and that's it. And vapor pressure, if you are in it drops, if that drops to the liquid's vapor pressure, then bubbles form due to vaporization. Because of high pressure areas carried, so collapses suddenly and made this damage is called cavitation. Compressibility is nothing but K is equal to stress by strain, and surface tension and capillarity with respect to water striders. Cohesion means same substances, adhesion means different materials it will attract. If different materials is dominated, that is called capillary rise, that is called concave. If same material is dominated, that is called convex, that is called capillary fall. So we'll see next lecture.